said is that the surface area?
The volume.
Very good. So this is indeed the volume because it's measured in cubic feet. Yep. Find the dimensions of the compost container with minimal surface area. And it says include the bottom and the top. Okay? Should I read it again or is it clear?
Yeah, that makes sense.
Okay. So now we have to create a function that is the surface area, including top and bottom. And we also have to remember what the volume of such a matchbox, if you want, is. Area of the base times the height, or length times width times height. So the volume is length times width times height. In this case, it would be x times y times 2x. X times y times 2x, which is the same with 2x squared y. And we know that 2x squared y equals 18. I will solve for y, which will be 9 divided by x squared. Divide both sides by 2 and divide by x squared. And of course, you'll see in a moment why we need that. So now the surface area has 2 front and back, y times 2x, twice 2x times y, front and back, twice sides, twice x times 2x, and 2 top and bottom, plus twice x times y. This is the surface area, and this is what we want to minimize. I have to clean it up. So this is 4xy plus 4x squared plus 2xy. I will combine these two and have 6xy plus 4x squared. Of course, I'm going to have to remove this and replace it by 9x squared. And now I can say this is a function of one variable. So this will be 6x times 9, 54x over x squared plus 4x squared, and simplify. 54 over x plus 4x squared. So this was the difficult part. Now the calculus part is pretty straightforward, I hope. Because I have to differentiate. I get negative 54 over x squared and plus 8x. And of course I have to set it equal to 0. And I find negative 54 plus 8x cubed divided by x squared equals 0. I have to find the least common denominator. So then I have to set the numerator equal to 0 because the denominator could never be 0. So 8x cubed equals 54. So then x cubed equals 6. I'll take the cube root, and I get that x equals the cube root of 6. And that is in feet. But who knows whether this gives a min or a max? Nobody. I have to show. If I don't show, I can't get full credit. So I have x. I have the cube root of 6 from 0 to infinity, not really, of course. S prime of x, 0, and s of x. So I go back, and I cannot plug in 0 here. So, but I will plug in 1. So negative 54 plus 8, this is negative. And if I plug in 10, I have 80 minus something small. I want to determine this. And this should be the situation, because I studied the sign of the derivative. So I have to find it. It doesn't ask me to. Does it ask for the, it says find the dimensions. Okay, it says include the top and bottom. Okay, so it doesn't say to find the max, to find the actual minimum, but we can. We can punch in the function. I can punch this in and put in the cube root of 6 in here and just determine this. So this can be determined very easily. But I only determined x. Now I have to determine y. So y will be 9 divided by the cube root of 6 squared. And yes, I will have to approximate these values. So x is basically approximately what is the cube root of 6, 1 point what? So I like this. You can use the method you like, of course. 1 divided by 3. 1.82. And that's in feet. Don't forget measurement unit always. And the other one, the y is 9 divided by 6. Oh no, I'm going to do this. Previous answer squared, and it's 2.73. So y is approximately 2.73 feet, and the height will be twice times 6 to the power 1/3. 1 divided by 3. Because it's twice the width. So the height is approximately 3.63 feet. So now I have the dimensions of the box that will definitely hold 18 cubic feet of whatever compost, and will have the smallest surface area. It will use a small amount of material and still hold 18 cubic feet. But I have to show the sign of the derivative, and if I'm asked to find the surface area, I will have to punch it in the function, in this one. And I can do it right now in case we want to look at that. Okay, here it is. So that was 54 divided by the cube root of 6 to the power 1/3, and then plus 4 times 6, and it's squared, 6 to the power 2/3 then, because it's squared. So the minimum surface area is 42.93, and this is square feet because it's area. Very good. Anything else? Other questions?
I actually had a quick question about this one. There was, in my math lab, when you did one of these, there was a step in between when you did the derivative and finding the second derivative to determine if max or min.
Right, I don't recommend that. It will take you so much longer than simply, I mentioned that's the difference between using the first derivative test and the second derivative test. I saw some of you.
I didn't know if that was like the replacement that they gave for the table that we're using. I just wanted to make sure that it was, the same thing.
Absolutely, you can use it. You can. But in order to study the sign of that one, you have to, first of all, the next step is to find the second derivative and then study the sign of the second derivative. So those are 2 additional steps. I'm fine with it.
They do this. They walk you through certain problems if you do I need help so that it'll break down.
Right. And
it was just a different way that it did it, but I just wanted to make sure that
oh,
it
yes.
was the exact same.
Yes. If you remember when we talked about, very good question, Amanda. When we talked about the second derivative test, I said, I don't use it. And the reason why I don't use it is because it's too late for me to find my errors. If I wait to determine the second derivative and I already have an error in the first derivative, then I wasted half an hour. So I'd rather study the sign here and not have to wait till the second derivative. Because if this is wrong, then I have to start from scratch. That's why I stop and make sure that these two rows work well together, and then I go to this one. I may not even need the second derivative. But it's okay. It's a good method. It's the second derivative test. You are testing whether the function opens up where it has a critical number, so it must be a minimum. If the function opens down where it has a critical number, it must have a maximum. There is no question that this is true. It's the second derivative test. But it involves two more steps that take time. And sometimes the second derivative is really more difficult to study than the first. But thank you so much for bringing that up. It's a very good point.
Thank you.
Thank you. Good. Next question about anything.
I do have another one.
Yes, I'm ready.
I think the term is relative rates that we did last time.
Yes. Related.
Question.
Yes.
Related rates.
Related
Question I had in the
rates.
homework
They
was
are
rates.
related through an equation. Yes.